feel free to write on it. Okay, number one. No, the first one's not a function. It fails vertical line test. That's your reason. Some of the reasons I thought were weird. I'm not sure where you came up with some of these reasons, but just fails vertical line test. Remember, we talked about it. If you have more than one output for an input, it's not a function. Clearly, if you draw a vertical line, it passes more than once. Not a function, right? Next up, the domain. Domain I thought was fine for this one. The range was fine. You can do interval notation or inequalities, up to you. It's between -4 and 4 for x, between -2 and 2 for y, inclusive. For the second one, it is a function. It passes the vertical line test. And again, I saw some really weird reasons. Really, it's just if there's one output for one input, it's a function. That's all. X is greater than or equal to -2. Y is greater than or equal to -1. For number two, okay, we definitely have to retest this for sure. Okay, now actually, let me talk about the retake policy right now because I think you guys need to know it. Here's what we do for future tests. We will deliberately test old concepts from a previous test. So test number 2, which I'm not sure when that is. I think it's the end of the month. Test number 2 will have questions from this exam. About 30% of test number 2 will have questions from this exam. Definitely number 2, I need to retest. What we do is that we take a look at the old problems on the future tests, and we give you a subscore. That subscore acts as a retake. So we don't do a separate retake because that's too much. We tried doing that last year. It didn't go well because people just weren't ready. They had to prepare for the actual tests, and then they had a retake test. It was just too much. So what we'll do instead is every future test will also act as a retake. We'll have a cumulative portion, if you want to call it that, that will be a subscore, and we'll use that to average with this test. So if you got less than 80%, you're eligible for a retake, and I'll average those. Go somewhere good.
Also, like, text and they do kind of have to have the retakes. Will you like how you know this test in the back, like have this section? Would you have it for like parts you need to study on?
Right, I will. Yes, yeah, I'll definitely disclose what you'll need to know exactly. But this is one problem that has to be reassessed because, yeah, it didn't go too hot. If you just think about it, you're starting at -2, you're ending at 5, so make sure your graph shows that. And you're starting at -6 for y, ending at 4. Make sure your graph shows it, and make sure -2 is not included and 4 is not included. It's very simple. If you so desire, you could have done it like this: -2, 4, and 5, -6. That could have worked, right? So that's a possibility. So that's a lot of ways you could have done that one. All right, number 3. Let me explain what's happening. So some of you guys forgot to circle. It's right there. I don't know why I forgot to circle increase, decrease. Okay, what is a question asking us? You have to first figure out what's independent, what's dependent. Independent's X, dependent's Y. So independent would be age, right? So you have to say the age in months, and dependent's price. As age increases, what does the price do? It drops. That's all. That's all you have to say. Yes, you can also look at it at the years, but that's not what's on the x-axis. The x-axis is simply the age of months. You compare the age of months to the price. As the age goes up, the price goes down. That's it. Correct. That's why you missed it. Right. Okay. Number 4. Okay, A and B are fine. I don't think that was a problem. There might have been a careless error they may have made. A is 21, B is 2. I saw someone put 9 plus 12 was 17. You have a calculator, guys? So I don't know sure why. You have a calculator, so I'm just baffled. Okay, now C. All right, just saying. All right, now this also was also a little disappointing too. I saw some really weird stuff here. All you have to do, guys, is plug 1 in. That's 5. Plug 5 in G. 4/10, done. I saw some people doing this, like x squared plus 4x times 4 over x plus 5. Well, this tells me you're not looking at your notes. You did not study your notes if you're doing this, because I never done that. If a tutor did that to you, fire that tutor today, because I did not do that. It's not times, guys. It's plugging into a function. Plug a 1 to F, then take that output, plug in the G. That's it. So we're good. I can't. No, I do take up half points. I'll look at your test. I could tell you the rubric, why maybe you got a full point, but maybe I did grade quickly, so if I have to like look at it again, give some points back, I could do that too. That's not a problem. But I do give half points. I do. Sure, you have a question. Right.
That was just thinking of a question, but if I like on the previous problem, the number 3,
Mhm.
just worded my sentence differently, but it basically.
Let me take a look at it. I'll do case by case. Yeah, I'll take a look at it. Yeah, and guys, don't worry. You guys can still come back and talk about the test. Not a problem. All right, for D, we've been doing a factoring packet for a reason. And some of you guys are doing this. Like, I was really baffled and kind of sad that you guys are doing this. Like, seriously, you guys took Algebra 1 2 years ago and passed out of it. You shouldn't be doing that. That makes no sense. Taking a square root. I don't know what that is. Move everything to one side, factor it, and solve. That's it. That's all you have to do. That makes no sense to square root. Yes, you see an x squared, but you see a plus 4x. So I don't know what that even is. Just move everything to one side and factor it. That's all you have to do. For E, -5 makes it undefined because you can't have 0 on the bottom. So that's all. Okay, this was also didn't go too hot for some of you guys. If you set it up correctly, that's fine. Just factoring. That's all it is. X squared plus 6x plus 5 equals 0. You even have a calculator. You can plug it in and see where the x-intercepts are. That works too. But remember, you need to give me the y values too. You can't just give me x. Some of you guys just gave me x. I took up a point if you didn't give me y, because at least I got most of it. Some of you guys factored it in correctly, and then the rest went by the wayside. So, but that's the answer. Just set them equal, put everything on one side, factor it, and you're good. Some more?
Are we gonna first take these home?
You can take them home.
Are you gonna this the video or something so we can like put them for ourselves and see what we got wrong this time? Like, you know,
Oh wait, sorry. Repeat that.
send us the video you did.
Yeah, of course. Yeah, totally, 100%. Yeah, 100%. I'll definitely upload this later today. I think we definitely have to reassess 4C and 4E and 5. Those have to be reassessed for sure. Okay, move on to 6. 6 I thought was okay. If you missed it, probably just didn't graph. I don't know what happened, but just graph the line, graph the parabola, use your calculator. That's all. And see where they touch. We talked about how they touch. We did do this. We practiced this skill in our notes. For 7. Okay. The asymptotes. We talked about it. Okay. The asymptote is what makes the bottom 0. Okay. That's a forbidden region. We talked about this. That happens at x equals 2. So you put x equals 2 for the equation of asymptote. Also, you see that it levels off towards -3. Let me actually pull up a graphic calculator to show you how to do it. So let's see here. Nope, that's not it. Math departments. Wabbits, CMU. All right. Okay, cool. Here we go. So when you type it in, should be typed in like this. Y equals. Now you gotta do 6 over parentheses. Some of you guys didn't do a parentheses. Or maybe, I don't know. And then -3. And actually, I should put this in parentheses as well. And I don't know why it's not responding. Hold on. There we go. And there you go. Right? That's what's happening. It's pretty obvious the y-intercept is -5, I think. You can plug in 0 for x also. Sorry, -6, my bad. And the x-intercept will probably be 4. Yeah, it's pretty close to 4. And if you're not sure, just plug 4 in, see what happens. You get 0 for y. So that's pretty simple. And it's leveling off towards -3. That's a horizontal asymptote. We did discuss this in our last notes. So as x gets really big, y is getting closer and closer to -3. So that's what's happening with that one. Okay, for number 8, that was fine. I don't think that was a problem. Definitely we have to reassess 7 though, that's for sure. For number 8, that was fine. One thing I was a little confused about, can we guys give me negative values for x? What does x represent? The number of weeks, right? Where does it say that? Yeah, x is the number of weeks. So you can't have negative weeks. That's strange. So I don't know. I didn't take up points for that, but that's just strange. So just be careful with what you're doing. Okay, 9. 9 also didn't go too well. You have a calculator. Just plug it in. So root 4 minus x minus 3. There we go. Okay, the calculator can be a little deceiving. So if you hit trace, I know it doesn't go spot on to 4, -3, but think about it. It's going to get there because you could plug in 4 and get 0 for the radical, and 0 minus 3 is -3. So some of you guys didn't show me that. What that tells me is you're relying too much on memory, not on understanding. You have to understand it starts at 4 because you can plug in 4 and it's -3. The x-intercept, not that hard. Just it crosses at -5, and plug in, you get 0 for y. Jasmine, go ahead. Oh, so 4, because if you plug 4 in, you get root 0, which is possible. That's totally possible. So your domain has to go up to 4. So -infinity to 4, or x less than or equal to 4, and y is greater than or equal to -3. Yeah, so that's what's happening there. So anyway, I'm hopeful that this is your wake-up call and that you guys start taking your preparation more seriously. Office hours, check your notes. All right, talk to me. I'm here to help you guys. All right. Okay, let's start the new unit. Unfortunately, the photocopy machine is broken, so I can only photocopy about 10 copies. So I'm just going to put a couple copies. So yeah, unfortunately, the machine's not working. So probably could designate a couple people to be note takers, and just rest could just watch, and I'll just prepare more notes when I get a chance. So I'll put a couple per table. You'll have to take the sharing them. Okay, let's get going with the notes today. All right, you do need graphing calculators, so please get your calculators out. If you don't have any, I will lend some. Yeah. You pass out another one for calculator? Oh, no, you just have to share. Oh, yeah. And we need a calculator? We do? Yeah. And also need a calculator. Except you have 4 here. Your calculators. Calculators. You guys have calculators? Good. All right. Okay. My apologies with the notes. Again, the machine's just not responding. So, all right. So, just have to share the notes for today. And what I'll try to do is I'll try to have these filled out, and I'll share with you guys tomorrow. Okay, so let's start with this new type of equation called y equals b to the x. And actually going back to what we did back to school night. Sorry, first day of school. I did this back to school with your parents last night too. You might remember we had this little presentation I did with you guys on day 1. Remember I talked about Star Wars and I talked about this? Okay. So we've definitely covered linear functions. We've definitely covered this, one over x. We're going to do this in more detail. We're going to talk about this today, exponential. We're going to talk about this today. Quadratic we'll get to in October, I think, which you guys have seen. We did talk about square root. So we've already been doing some of these already. So and we're just going to keep at it. So y equals b to the x. That's again like this one, an exponential function. That's the new topic. I'll read the first paragraph and we'll do some practice problems. You already know that equation in the form y equals mx plus b represents family of lines, and you know the effect of changing the parameters of m and b has on the graph. Remember, m is what again? What does m represent? Slope. Good. Okay, that's a slope. And that's y-intercept. So if you change y-intercept, it crosses either higher or lower, depending on what you do. The slope can make it steeper, more shallow, depending on what you do for m. But now we're going to talk about this. Exponential functions. All right. So here's what we're going to do. We're going to graph a few functions, just see how it changes. So in your table groups, here's what I'm gonna ask you to plot. We'll go y1 equals y2 equals y3 equals y4 equals. So let's try 2 raised to the x power. Let's do 1/2 raised to the x power. And I'll do it as well with you guys. Let's also do 3 to the x power. 1/3 to the x power. Let's start with that. So if you go to the calculator and just do one at a time. So let's do 2 to the x power. You should have this. Do you guys know how to do powers, by the way? The caret symbol. It's right below clear. So if you graph that and hit zoom, option 6. So you reset the window. So well, let me back up a little bit. Let's turn on the calculator. Let's go to y equals. Let's type in the equation. We'll do 1 for now, 2 to the x. And it helps to reset the window to option 6. Hit zoom, option 6, it resets the window. And here we have this graph. And jot down the graph somewhere in the notes. So obviously y equals, so for y1, it looks like this. And let's kind of just take some time to kind of simmer on that graph. I know simmer, it's a good word, right? If you're in the cooking, it's a good word. All right, so take your time just to focus on that graph. So if we take a quick look here, let me ask this question. For y equals 2 to the x, and let's take a little time here. Where does it cross the x-axis? Or does it cross the x-axis? Where does it cross the y-axis? Is there an asymptote? We're going to talk about that also. Tell me the domain. Tell me the range. So we're going to really deeply analyze this graph. Okay. So looking at the graph, where do you think it's crossing the y-axis, guys? 1. Good. Think of it. It crosses at 1. If you plug in 0 for x, right? It crosses at 1. Right? Totally crosses at 1. So that's the y-intercept. It's at 1. If you plug in 0, you get 1 for x. Sorry, 1 for y. And plus, just look at it, right? It definitely, if I trace, it's not going to be spot on, unfortunately. Oh, it is in this case. But Desmos would be spot on, right? If you kind of get close on either side, you see it gets close. It's pretty much 1, right? Now, let me go to the left. What happens as I go to the left? What's happened to x as I go to the left? What's x doing? X is what? Well, it's negative. X is getting is a bigger negative number, if that makes sense. Or it's actually technically getting smaller, but it's going towards negative infinity. So when x gets more negative, what's happening to y? What's y getting closer to, you think?
0.
0, totally. Good. Now, can we make it exactly 0? No, you can't. So there's no x-intercept. There's none. The reason why is that 2 to the x is 2 times 2 times 2 times 2 times 2 times 2 repeated. In order to get that to be 0, you need one of those numbers to be 0. That just can't happen. That's just not happening. So yeah, if I have a bunch of 2s, it's going to be a big number. So if I go to the right, what's going to happen if I go to the right? Okay, it's going to start increasing, right? If I get to 0, okay, now if I keep increasing, what happens to y? It gets bigger, totally. That's why it's called exponential. Exponential growth means when things are growing very quickly. For example, when COVID was happening 4.5 years ago, you saw a lot of people getting COVID, right? That was an exponential increase. And of course, it had to level off because everyone got sick, but that's when things rise very quickly. So what do you guys think the domain would be? Do you see any restrictions? Do you see any reason why there's an x that should be excluded? Or can we include all x values? Can we include all x? No? So what x values can be excluded? Was that? Or I can include all of them. Yeah, there's no reason why anything can be excluded. Everything can be included. So that's gonna be all real numbers. So you can write like this. I'm gonna start doing interval notation because you just have to start doing that. So I'm gonna write like this. That means all real numbers. This means I can go forever to negative infinity. I go forever to right positive infinity. Now the range. Do we know the truest lowest value for y? Or what does it get close to for y? As I go more to the left, what was it getting closer to? Zero, but not spot on. So I put a parentheses. It's not spot on. And then is there a ceiling for y, or does it just go up? Sky's the limit. Sky's the limit. It goes up forever, right? So here we go. Sky's the limit. That's your range. So your range from 0 to infinity, non-inclusive, and domains all real numbers. If you still need to see the old way of writing domain range, that's okay. I'll do right here. All real numbers. Just so you know. And the range is y is greater than 0, but not including 0. Okay.
Could we do that instead when we show that point?
Yeah, eventually we're going to transition to interval notation. Eventually we're going to. Charlotte, go ahead. Sure, yeah, totally. Evelyn, go ahead.
Round parentheses, not including.
Yes, so you just put a parenthesis. So that's just y is greater than 0. Exactly. Now, if it's including it, you put a bracket, but we're not including. Lastly, the asymptote is going to be this. Okay, we talked about asymptotes before our last test. The asymptote is a boundary, okay? And now I'm talking about it. So actually, I think it was F period. It wasn't you guys. I think it was F period. Some people in ASC were saying I didn't talk about it. I was like, no, I did. It's a boundary. There's a boundary for the bottom, right? It doesn't pass that boundary. It doesn't cross it. So that's what's happening. Let's go. That's for y. We're talking about a boundary for y, not for x. Because it's hitting a bottom. So because x is left, right. Y is top, bottom. There's definitely a bottom. It bottoms out, which is impacting the range, not the domain. So remember, range is vertical, top, bottom. There's a bottom. There's no top. So that's why it's from 0 to infinity. The domain is left, right. I can go forever here, forever there. There's no boundaries. So that's why it's all real numbers, right? Think of the domain as that, like, right? It's all real numbers, but the domain, the range has a bottom. So all these other functions are going to follow the same thing. Let's mix it up now. Sorry about that. Let me erase some stuff here. Okay. Oh, y equals 0. Because that's the boundary that we can't cross for the y value. Didn't mean to do that. Let me undo this. Okay, let's keep moving, guys. All right, next up. Let's do 1/2 to the x. So I'm gonna go to y equals. I'm gonna keep y1 as is. I'm gonna put parentheses 1/2 raised to the x power. Okay. Now I'm gonna turn off the first graph. I'm not sure you guys know how to turn off graphs. It's really simple. Go to where it's highlighted and just hit enter and hit down. You'll see it's off. So enter toggles it on and off. Very simple. Some more good. So the asymptote, what you do is when you look at the graph, let me go back to the first one again. You want to see if the graph kind of levels off towards some horizontal line, which it does. You see how, like, as it goes this way, it gets closer and closer to the x-axis, and that equation is y equals 0. Because y equals 0 is the same thing as the x-axis. So that's what happens when you have horizontal asymptotes, is that it just kind of dives into a certain, it gets flat.
Okay.
So the graph itself looks like a horizontal line, even though over here, that doesn't look like a line. That's a curve. It's curving up pretty quickly, but off to the left, it looks horizontal.
Okay.
So that's really what's happening, is that part of the graph looks like a line. Now let me turn off the first one and turn on the second one. Okay, what change do you see now? How's this different from the first one? 1/2 to the x. So is it increasing or decreasing? It's decreasing, right? As we go from left to right, it's dropping now. Before it did this. So this right here was y equals 2 to the x. This next one needs some space here. Is y equals 1/2 to the x. Now, domain. Do you think the domain changes? Still the same, right? There's no need for a restriction. You can do whatever you want. So still all real numbers. Okay, the range. Let's investigate the range and the y-intercept. Let's trace. Okay, still 0, 1. If I plug in 0, it's still 1. If I go to the right, what happens to y, guys? If I go to the right, what's happening to y? Get closer to 0. Totally, 100%. But it's not gonna be 0 spot on, because what if I multiply 1/2 a bunch of times? Just 1/2 a bunch of times, right? If I multiply 1/2 over and over again, I get a fraction, but I don't get 0. What has to happen if I multiply a bunch of numbers to get 0? I need one of these numbers to be 0. But you're stuck with 1/2. You have to multiply over and over again. That's how an exponential function works. So the range is still, so there's still no x-intercept. The y-intercept is still 1. The range is still 0 to infinity, or basically y is greater than 0. And the asymptote is still the same thing, still y equals 0. So nothing really changed, except for the fact it's dropping instead of increasing. Lincoln, go ahead. Sure, yeah, totally, yeah, 100%. Not a problem. Yeah, Jaslyn, go ahead. 100%. Yes, they would be. Yes. Regardless of what B is. So this is a great observation that Jaslyn made. Regardless of what B is, and let me I'll say that, I'll say it at the end. But regardless of what B is, I mean, I'll type it up at the end. The domain range won't change, right? They'll, unless if you do like a shift, which we're not there yet, but we'll talk about shifts to graphs in a little while. What else I need to say? Oh, we call this growth. We call this decay. Let's look at a few more, and then we'll move on to the next page. So whenever you see an upswing, that's growth. Whenever you see a downswing, that's decay. So let me go and clear. Actually, I won't clear. Let me just go back to the calculator. All right. Okay, let's switch. Let's put 3 to the x. 3 to the x power. And let me turn off the second one, so it's not distracting. Decay, correct. When it's decreased, that's when the base is less than 1. I'm going to talk about that in a moment. Okay, let's look at 3 to the x. Okay, it's back to growing again, right? It's growing a little more in a steeper fashion. Because what if I turn on the first one and compare it to the third one? It's hard to tell, but 2 to the x, you see, it doesn't increase as sharply as 3 to the x. 3x will increase more sharply, as it should, because of the bigger base. The bigger the base, the steeper the increase. The lower the base, the more shallow it is. So that's another thing that's happening too. So 3 to the x is very similar. Those are similar. But 3x is steeper. That's definitely a steeper graph. And if I do 1/3 to the x, let's compare that to 1/2 to the x. One third raised to the x power off, on, off. Here we go. Let me go and clear a screen because it's a little distracting. Okay, notice that 1/3 of the x comes in a little bit more steep, which is kind of interesting. So we notice that as well. but it's still decay. So this is also what we want to say at the bottom here. Is that when B is greater than 1, that's growth. When B is between 0 and 1, that's decay. And also, as B increases, the graph is more steep. As B increases. But for decay, as B gets closer to 0, the graph declines more sharply. Declines more sharply. So you tend to see a sharper decline when that happens. Okay, hope that makes sense. Domain's always going to be all real numbers. You got Alexander? Okay. The range will be y is greater than 0. No x-intercepts. 0, 1 is the y-intercept. And the horizontal asymptotes is y equals 0. All right. Okay, so that's the observations we're seeing with this graph of exponential growth and decay. Things will change if I have to move graphs up, down, left, right. So we're not there yet, but the range will definitely be different if you do move things around a little bit. For example, if I do this, and we'll talk about it right now because I think it's good to talk about. And actually, let me save this as a screenshot. Yeah, so this is good because actually I should do this because this is what you really need because I didn't have notes for everybody. My apologies for that. I should have checked the copy machine earlier. We're going across campus. Really quickly, let me turn off 2 and 4. Let's go back to 1. And let me ask this question. What if I put a +5 at the end? Anyone want to take a stab what that does? That +5? It sounds good. Not quite the slope, but if you're adding 5 to the whole function, Evan, what do you think? Yes, exactly. Guys, y-intercept's going to change. What's y-intercept right now without that 5? It was 1. If you add 5, what's 1 + 5? 6. There you go. So this is the beginnings of transformations, which we'll have a full unit on in a little while. But you see how that changes the range. Now the range is y is greater than 5. And the asymptote's y equals 5. Because if I were to trace and move to the left, what's y getting close to, guys? 5. It's getting closer to 5 as I go to the left. So that's just something to observe. Another thing I want to talk about too really quickly. Let me clear all these right now. Hold on a sec. Clear. Okay, this is where we have to think critically now. Not memorize. Let's take let's put our thinking caps on. What if I did 1 to the x power? Okay. What do you think is going to happen if I do 1 to the x power? Just a straight line, yeah. Just y equals 1. That's not exponential at all. So that's why we don't do b equals 1. We do b greater than 1, not b equals 1. What if b equals 0? What do you think is going to happen?
Same.
Yeah, it's just going to be just coincide the x-axis. You don't even see it, but if I hit trace, it's on the x-axis. Lastly, this is where it gets really weird. -2 to the x. What do you think is going to happen there if I make it negative base? What happens if you do -2 squared? What's -2 squared? It would be 4, but then what if I did -2 cubed? Negative, so it's gonna go haywire. It's gonna go up and down like crazy. Actually, I don't see anything right now. I don't know why. It's being weird, but I think the other reason why it's doing that too is that sometimes when you have a fraction exponent, it could be like a radical. We haven't talked about that yet. And it's trying to take a square root of a negative number. So it just doesn't show. Yeah, it's just not showing. It's just really weird. If you go to Desmos, I think Desmos might do a better job of that. So here, if I do y equals parentheses -2 raised to the x power. Yeah, see, it just does this weird stuff. It's just acting really weird. So we never deal with that. It should be right because it's because you're increasing more quickly. All right, so let's do one more exercise, and then when do we get out at 35? Okay, so yeah, and then we'll be done, and then yeah, just I'll have to publish the homework to schools. You guys will just have to print it from home. If the copy machine works, I'll try to get more copies. All right, so here we go. So last activity. Y equals 1/2 to the x. We have it right here. Now, describe what happens to x to y, sorry, as x gets bigger and bigger. So eventually, y gets smaller. Or y gets closer to 0. But not exactly 0. And the reason why is that what if x are 20? What does that mean? How many times are we multiplying 1/2? 20 times. Will that ever be 0? No. Because you need to have one of those numbers be 0. But you can't because of the nature of the equation. Exponential just means you take the base and multiply it x times, right? So that can't happen. So does it have an x-intercept? No. Explain how you know. That's because y can never equal 0 when the base is not 0. And remember, your base is b. That's the reason why. And again, I'll take a screenshot of this in a little bit, so you guys have it. Okay, so look at C now. When x is very large, a graph of that approaches the x-axis. Okay, we know this. As x gets larger and larger, farther to the right along the curve, the closer the curve gets to the x-axis. In this situation, it's called an asymptote. You can read more about asymptotes in the math notes. Yeah. Anyway, what do he wants to do with that one? Okay, does it have a vertical asymptote? Okay, got it. Let me readjust this. Hold on a sec. Actually, I can't really readjust. I'll just do a screenshot. All right. Okay, so yes, parts didn't really say anything. It just so y equals 0 is a horizontal. Well, I'll just say that. And let me put this at text box. I did say I was going to do that. A horizontal asymptote is an equation that infinity. Okay, that's a horizontal asymptote, guys. It's an equation that represents what the graph gets closer to as x approaches positive or negative infinity. So the graph gets closer y equals 0 as x approaches positive or negative infinity. It is a boundary in some ways too, but I have to be careful about that because we are going to see situations. This is the part I'll have to kind of correct you guys in a little bit. You can cross horizontal asymptotes. That is a possibility. We're not there yet, but we'll talk about that when the time comes. But for now, it looks like a boundary, so we'll go with that. Because it does look like it gets closer to zero and doesn't touch it, right? Now for D, does it have a vertical asymptote? So basically, is there a forbidden X value? And the answer for that was a resounding no. So in other words, is there a vertical line that the graph above approaches? No. And why not? Our domain is all real numbers. So that didn't happen. Remember when we had y equals 1 over x? What was forbidden? What can I not plug in for x here? That would be a vertical asymptote. But I don't have that situation for 1/2 to the x. I can plug where I want for x. So all is good. And then E, can you consider that to be exponential? No. And that's because they're horizontal lines. So that's what's happening there. Okay, let me take a screenshot of that as well. Okay. So that covers the notes. Actually, there's one more page. Let's go over that and then we'll be done for today. All right, and this is where I'm gonna just give my voice a little bit of a break. John, can you read this paragraph right here back on the last page of the notes, graphs with asymptotes?
Which one?
On page 3, yeah.
The mathematically clear and complete definition of an asymptote requires some ideas from calculus, but some examples of graphs with asymptotes might help you recognize them when they occur. In the following examples, the dotted lines are the asymptotes and their equations are given. In the 2 lower graphs, the y-axis x equals 0 are also an asymptote.
Thank you. Yeah. So we did have this in the previous notes as well, right before our test. So this one right here is kind of what we did on the test. We had something like this on the test. Actually, it's pretty darn close to that one. But it could also look like this, where it oscillates. This is kind of like that's oscillating. It's going back and forth. We don't really work those kind of functions, but that's what's happening there. So that could happen. Obviously, this has a vertical. Let me write that better. Sorry about that. A vertical and a horizontal asymptote. We won't get to this until probably pre-calculus, but this is obviously a slant. For those, anyone play football in this room? Some play, yeah, you know what a slant is, right? When you run instead of up down the field, you're the diagonal. So you could have that. You could have a parabolic asymptote. That's a possibility. They do get kind of funky. But we won't deal with the funky ones in this class. We just really deal this here. Let me have someone read. Aiden, can you read the next paragraph where it says, as you can see?
However, in this course, asymptotes will always be horizontal. Graph of function as a horizontal asymptote. If, as you trace along the graph, as you trace exponents pointing to the other zero, either to infinity or to negative infinity. The distance between the graph of function asymptote is zero. Graph is a vertical asymptote. If, as you choose x coordinate closer and closer to a certain value, either left or the right or both.
Right. Yeah, so that's what happens for vertical asymptotes. Like if you were plugging values very close, we did this in our last class before the test. If you get closer to like x equals 2 here, apparently y goes up or down forever. But if you go bigger for x or more negative for x, it gets closer to 3. So this is what we'll deal with those kind of equations. All right. So I'm done. So we got about 4 more minutes left. I'll let you guys out about a minute early for lunch. Homework's right here. Again, I apologize. I don't have copies for everybody. I will upload this to Schoology. If you come back during office hours today or during lunch, I'll have copies ready, so my apologies. And I do have the screenshots and I'll post that as well. And then office hours, yeah, for those who are on office hours contract, come see me this week. All right, I sent an invite for it. And we'll just keep working through this stuff, okay? All right. Yep.
Can I take a photo of the work together?
Sure, yeah, sorry, yeah. Yeah, let me stop this one sec.